Before going to start, if you are new to my channel, please subscribe my channel. Let us start. So complex number is a number expressed in the form of z equal to a plus ib, okay? Or else we can also represent in terms of x plus I y, okay? Both are correct. Then where a and b are what? Real numbers. I is equal to what? Root of -1, that is iota. The real part of z is given by a and the imaginary part of z is given by what? B, okay? So how we can represent these complex numbers in plane, or we call it as complex plane. We call that as organ diagram. So complex number z equal to a plus ib, how we can represent in terms of plane. So with the examples we can understand here. Let us take here these examples a b c d. So first what we have to do, we have to plotograph x axis versus y. X is what? Real part, and b is y is what? Imaginary part, okay? So first write down the numbers here, real numbers and imaginary numbers. Then first example, let us take 3 plus 2i. So 3 is what here? Real number, real part, and 2 is what? Imaginary part. So 3 we can just see here, this is 3, and 2i is what? Here it is 2i. So this is the example for first example, 3 plus 2i. And then 3 minus 2i, how we can represent? 3 is on the positive x-axis and minus 2i. So here it is minus 2i. So this is the example for b. Minus 2 if we take, how we can represent here? This is the negative x-axis. So minus 2, this is how we can represent real and imaginary parts of a z, how we can represent in plane. So fourth one, 4i. So here it is on the imaginary part, that is 4i. So like that you can just represent the complex numbers in a plane, okay? And one more thing, the distance of the complex number from the origin of the organ plane is called the modulus of complex number. That is, we represent it by mod z. What is mod z here? Distance of the complex number from the origin of the organ plane. So that is mod z. Sometime we usually write r. Mod z is equal to r. Nothing but a plus ib or x plus iy. So if we take mod of z, that is equal to what? A square plus b square, root of that, root of real part and imaginary part. Next, one of the very important topic, that is complex analytic function. Very important as per your exam purpose. First we should understand the definition of analytic function. A function f of z is said to be analytic at point z equal to z naught. Two conditions it has to satisfy. First one, it is single valued, and second one, that is it has a derivative at every point in the neighborhood of z naught, okay? The function f of z is said to be analytic at point z equal to z naught if it is a single valued and has a derivative at every point in the neighborhood of z naught. Otherwise, we can also define the function f of z is said to be analytic in domain D if it is single valued and it is differentiable at every point of domain D. Nothing but reason. So Cauchy-Riemann equation for the function to be analytic or not. So let us take the function f of z. It must be equal to u plus iy. that is to be analytic at every point in some region R. So necessary conditions here, this is the first condition, dou u by dou x equal to dou v by dou y, and second condition, that is dou v by dou u by dou y is equal to minus dou v by dou x. These two conditions must be satisfied if a function is analytic. And one more thing, these derivative of u and v with respect to x and y must be continuous functions. And derivative of f of z and its conjugate is given in terms of plus I and minus I. So these things you have to keep in mind. Let us take one example. Whether f of z is equal to sin z is analytic or not. We have to check this given function is analytic or not. So first what we have to do, f of z is equal to sin z, we have to take z is what here, complex number, that is x plus iy, we have to write in terms of that. Then we can write the formula for sin a plus b. According to that you can write the equation here. So this cos iy is what in terms of hyperbolic function. So sin x plus cos hy, I cos x plus I cos x sin hy. So after converting in terms of hyperbolic function, then we have this given function in terms of u plus I v. Okay, so u is equal to what, sin x cos hy, v is equal to cos x sin hy. Then differentiate these u and v with respect to x and y. Then after differentiating, you must verify these two conditions, dou u by dou x is equal to dou v by dou y. Here you can see cos x cos hy, dou v by dou y is what, cos h cos hy. So this condition is satisfied. So next condition is what, dou u by dou y is equal to minus dou v by dou x. Dou u by dou y sin x sin hy, and dou v by dou x is what, minus sin x sin hy. So these two conditions are satisfied. So Cauchy-Riemann equation is satisfied given f of z is analytic. So like that you have to check the given function is analytic or not. Next example. So whether 1 divided by z is analytic or not. So let us check. So first what we have to do, take w or f of z is equal to u plus iy, that is equal to 1 divided by z. So this 1 divided by z is what, x plus iy, that is equal to x minus iy. Just you have to multiply numerator and denominator by x plus iy. You will have x minus iy divided by x square plus y square. Then it is in terms of what, u plus iv. Then you can take the value of u and v and differentiate u and v with respect to x and y. So dou u by dou x, if you differentiate carefully, you will have the value y square minus x square plus y square to the power whole square. Next differentiate u with respect to y. So you will have these two conditions. Next differentiate v with respect to x and next v with respect to y. Then check the conditions, Cauchy-Riemann conditions. Here you can clearly see dou u by dou x is equal to what, dou v by dou y. Okay, this condition is satisfied. And next dou u by dou y is equal to what, negative of dou v by dou x. So this is also satisfied. So Cauchy-Riemann equation are satisfied. And one more thing, partial derivative are continuous at 0, 0 means at origin. So this given function 1 divided by z is analytic everywhere except at what, z equal to 0, because 1 divided by 0 is what, infinity. So it is analytic function except at z equal to 0. So if we take derivative of this function, that is equal to minus 1 divided by z square. So again we have to show that the derivative of the given function is analytic except at z equal to 0. So this is how you can check the given function is analytic or not. So this is how you can solve the problems related to analytical function in the complex numbers or complex analysis. I hope this video is helpful for you. If you found this video helpful, please like, share and subscribe my channel. Thank you for watching.